So today we're going to look at how we can use the derivative to find rates of change. But first, what do I mean by rates of change? Well, if you've been watching my videos, then you know that if we have some function f of x, right, then its derivative, f prime of x, will show us what the slope of that function is at any point that we plug in. So if we can find the slope at any point, we can also tell where the function is increasing, decreasing, or staying the same. If the slope is a positive number, then it's increasing. If it's negative, it's decreasing. And if the slope is 0, then the function is not changing at all. What I want to do is look at a graph of a function and see if what I just told you works, if it's really true, right? So let's say we have the function, let's say our f of x is equal to x squared, right? This is an easy one to graph. So we have f of x is equal to x squared. Now I'm going to do my best to draw a graph of this. So we have our y and our x axes, right? So here's x-axis, here's our y. And now we're going to draw our function of x squared, which is just a parabola. So we have it looking kind of like this. This is my best. And so if we look at this graph, right, we can look over here at the left side and say, okay, well, the slope is definitely decreasing right here, right? And then if we move over to the right side, the slope is definitely just staying, increasing, right? And then there must be some point in between where the function is staying the same, where that slope hits 0. So what we're going to do is find that slope and look at the intervals. Say somebody asked us on what intervals is x squared increasing or decreasing. We're going to look for those. So the first step to doing that is finding where the slope is not changing at all. So we're going to take the derivative first because we want our function for slope. So the derivative of x squared is just 2x. And we're looking for where the function is not changing, right? So that's where the slope is equal to 0. So let's just set 2x equal to 0 and solve for x. Now when we divide 2 by both sides of the equation, or both sides of the equation by 2, we get x is equal to 0. So at the point 0, the function is not changing because that's when our derivative is equal to 0. So let's test the left and right sides of the equation to see on what intervals it's increasing and decreasing. Obviously, we're going to know what this is, but let's just do some math to prove it, right? So what I like to do, you have to test the points on either side of our point where it's not changing. So our point where it's not changing is 0. So I'm going to test if x is -1 and 1 because those are simple numbers to deal with, right? So 2x is equal to 0. Let's plug in 1 for that. We have, not 2x is equal to 0. All we have to do is do 2x and plug in 1. So we have 2 times 1, and that's equal to 2. So we got a positive number. And if we put any positive number right here, we're going to get a positive number as our result. Same with negatives. If we do 2 times -1, we get -2. And any negative number here is going to result in a negative number right here. So we know that on the intervals from -infinity all the way up to 0, our slope is going to be negative. Therefore, our function will be decreasing. And the interval from 0 to positive infinity, we're always going to get a positive slope. So our function is always going to be increasing. So here's what we like to do, right? If we're asked that question, where's the function increasing and decreasing? I like to write, okay, increasing on the bounds. And when we're using infinity or negative infinity as a bound, we always use a parenthesis, right? So we have increasing from 0. Because 0 is not included, we're using a parenthesis. If it were included, we would use a bracket. So it's increasing from 0 to infinity. And then decreasing from negative infinity to 0. Now I want to look at another graph of an equation that is similarly easy, but it'll give us a different result this time. So let's look at that. What if our function, f of x, is equal to x cubed? Now, let me try and draw this for you again. This is a pretty simple one if you don't know what it looks like. So here again are our axes. That's the y, and there's the x. I tried to draw it as straight as possible. And then here's what the function of x cubed kind of looks like. I'm trying my best here. It's like this. Just like that. And if we look at this, right, it looks as if it's increasing the entire time. At least to me it does, right? I mean, like right here it's increasing. There might be a point somewhere around here where the slope is 0. I'm really not sure based on eyeballing it. but then right here it's for sure increasing again, right? So we want to find these intervals where our slope is increasing and decreasing, right? So like we did with the last one, we're going to start by taking the derivative, right? So the derivative of x cubed, power rule, we just get 3x squared. And we want to find where the slope is not changing again, right? So let's set this equal to 0. So we have 3x squared is equal to 0. Divide both sides by 3, we just get x squared is equal to 0. And then we get that x is simply equal to 0. So at the point 0, that's where our function is not changing. So we were right about like our little theory that right about here, the slope isn't changing at all, right? So let's do what we did again with x squared. We're going to test on both sides of our point where there's no changing. So we're going to use 1 and -1 again. And you can use any numbers you want on either side of 0. I just do 1 and -1 because those are the simplest to do. So our slope equation is 3x squared. Let's plug in 1 for that. So at 1 squared, that's going to be equal to 3. So we get a positive slope. That means we're increasing, right? And any positive number we plug in here will result in a positive slope. Now let's try 3 times -1 squared. And since we're squaring a negative number, it's always going to become positive. 3 times -1 squared is also equal to 3. So any negative number we plug in here is also going to result in a positive number. Therefore, our function is increasing across all bounds except for the point 0 where it's not changing. So here's what we'll do. We'll say increasing from -infinity to 0, parentheses, and then it's also increasing from 0 to positive infinity. And that's how you would do rates of change problems. That's how you'd solve a problem if it's asking you where functions are increasing, decreasing, where the intervals are, or at what point the function is not changing at all. If you made it to the end of this video, I really appreciate it. Thank you for watching, and I hope you learned something.